Welcome to Bridge Mathematics 1, Module 7, Topic 3, Measures of Variability.
What is variance? Variance measures how far or dispersed a set of data are spread out from their average value. There are two types of variance. One is the population variance, and the second is the sample variance. Population refers to each and every observation or value in a data set. Thus, the population variance is calculated based on the population. However, when the number of observations increases, then a few data points can be selected to represent the entire population. These selected data points from a sample, and the variance calculated based on this data is called the sample variance. The sample variance can be used to estimate the population variance. Remember, to be able to compute the population variance, you need all of the data of the whole population, whereas to use the sample variance, you only need a proportion of it. Pay attention to which type of variance you need to compute for. When can you use variance? Look at some common applications of variance in real-life situations. In finance, variance is a tool used by investors to assess the risks related to investment decisions by measuring the volatility of financial returns. Investors can reduce risks and safeguard their investment money by using the analysis of variations in asset prices or market indexes to guide their selection. In environmental research, variance is used to investigate the variability of the climate and how it affects the ecosystem. Researchers can evaluate trends and forecast future climate changes by examining variations in temperature, precipitation, and other climatic elements throughout time. In marketing and product development, variance analysis helps companies create new products. Businesses can find chances for new product innovation. In manufacturing, variance analysis is crucial to guarantee product quality and uniformity during production operations. In medicine, variance analysis is used to track disease outbreaks and evaluate patterns of disease transmission. It is possible for public health experts to identify outbreaks early and stop the spread of infectious diseases. Why do we use variance? As you can see from the scenarios presented previously, variance is essential to run many industries successfully, especially when trying to determine the risks associated with a given set of options. But how does variance measure up to other measures of variability? Here are a few strengths of variance as a measure of variability. 1. It is rigidly defined and based on all observations. 2. It is amenable to further algebraic treatment. 3. It is not affected by sampling fluctuations. 4. It is less erratic. When dealing with complete population variance is a constant, a parameter which helps to describe the population. But on the other hand, when dealing with sample from the population, the sample variance is actually a random variable, whose value differs from sample to sample. As a weakness, variance is also difficult to understand and calculate, and it gives greater weight to extreme values. How do you calculate the variance? To calculate the population variance, follow these steps. Step 1. From the dataset, get the mean. Step 2. From each data point in the dataset, subtract the mean, and then square the difference. Using a table to track the computations may be helpful at this stage. Step 3. Add all squared difference for all data points. Step 4. Divide the sum by the total population of the dataset. The sample variance formula is very similar to the population variance formula. You only need a single minor change. For step 4, we now divide by n minus 1 instead of n. To calculate the sample variance, follow these steps. Step 1. From the dataset, get the mean. Step 2. For each data point in the dataset, subtract the mean, and then square the difference. Step 3. Add all squared difference for all data points. Step 4. Divide the sum by the number of the samples minus 1. That was a lot, wasn't it? Let's try to apply these formulas in practice problems to help you understand them better.